With the same given, we're going to find the vector sum using your graphical method. But this time, we will be calculating it using your parallelogram method. So in the parallelogram method, you're just going to draw your vectors starting from the same origin. Drawing first, you have your vector A. So that is 5 centimeters to the north. And then we will draw the second vector starting from the same origin as we have at A. So we will use that one as our origin. So from that, we are going to measure 35 degrees north of east. So that is at 35 degrees. So from that, we are going to draw your vector B, which is 9 centimeters north of east at 35 degrees. So that is your vector B. This is at, again, 35 degrees. So in the parallelogram method, we are going to draw parallel lines to make a parallelogram. So one parallel line with your vector A, okay, which we'll draw from the head of vector B. So the parallel line should be parallel to your vector A, which also has the same length, okay, going to the same direction to the north. And we're also going to draw parallel line to your vector B of the same length, the same direction. Okay. So that violet lines there are the parallel lines of your vector A and then your vector B. And then we have already formed a parallelogram. Okay. Now the resultant vector is just from the origin towards the opposite side. So we're going to draw a diagonal line from the origin towards the opposite side. That red line is your resultant vector. So to find the magnitude of your resultant vector, you're just going to measure it again using a ruler. So that is at 12.5 centimeters. The direction is again measured using your protractor. Measuring that one, we get an angle of from your east towards the north, which has a magnitude of 54 degrees. So by the parallelogram method, we have obtained your resultant vector R, which is equal to your vector A plus your vector B. Your R has a magnitude of 12.5 centimeters, directed 54 degrees north of east. So in your parallelogram method, again, you're going to use diagrams to find for the magnitude and direction of your resultant vector. The difference with your head to tail is that in the parallelogram method, you're going to draw parallel lines with your vector, okay, and the resultant vector is measured from the origin towards the opposite side of your parallelogram, which is a diagonal. which is the diagonal line. It's measured from here towards this point here. Okay? This diagonal line here is your resultant vector. Okay? As you have observed by the head-to-tail method and then the parallelogram method, we have obtained the same values of 12.5 centimeters and 54 degrees north of east. We can also add more than two vectors graphically using the head-to-tail method. Consider, say for example, you have these vectors here, vectors A, B, and C. Okay? To find the sum of these three vectors, you can either have your A plus B plus C. Okay? We're just going to draw first your vector A, and then from the head of A, you connect your vector B, the tail of vector B, and then from the head of vector B, you're going to connect the tail of vector C, okay, this one, and your resultant vector is just from the tail of A, this one here, from the tail of E towards the head of your last vector, which is your vector C. Okay? If you have more than three vectors, you're just going to connect head to tail, head to tail, head to tail. Or you can also start with your B plus A plus C. Okay? So you draw first your vector B, and then you connect your vector A, and then connect your vector C. Your resultant vector is just from the tail of A towards the head of C. And this two, this one here, and also this one here, should just measure the same, since we're just adding the same vectors. Now let's discuss the negative of your vector. The negative of a vector is defined as the vector that when added to the original vector gives a resultant of 0. So it's represented as the negative of A. So in other words, if you have your vector A, if you add vector A with the negative of vector A, the two should give a sum of 0, meaning they have the same magnitude but they are directed in opposite directions. The negative of the vector will have the same magnitude but point in the opposite direction. Say for example, if this is your vector A here, okay, your negative vector A is of the same magnitude but it points towards the opposite direction. In subtracting vectors, it's just the same way as you're adding vectors with the negative of your second vector. Let's say for example, you want to subtract vector B from A here. You have your vector A minus B. This is just equivalent to adding negative B to A here. Okay. Now let's proceed to multiplying a vector by a scalar. So if, say for example, C is a scalar, the product of CA has a magnitude of C times A. Like say for example here, you have your vector A, and then you multiply it with C of magnitude 2. What you do is just multiply the magnitude of A by 2, meaning your vector A now will be twice as long as your A. Multiplication of vector by a positive scalar and a negative scalar is different. If you're going to multiply a vector by a negative scalar, like say for example you have C equals negative 3, you multiply A, your vector A, by 3, meaning your vector A now will be twice as long as A. But since you're multiplying it with a negative scalar, the direction of your vector A will change, as shown here. That is, you're multiplying a vector by a scalar is just straightforward. We now go to the analytical method of adding vectors. The first method that we have described in your analytical method is your at right angles. Okay. However, in your right angles, we can only use this one to up to two vectors which are at right angle with each other. So say for example, consider this one here. This is your vector A. And then we have another vector, vector B. Sorry, let me draw it again. And then I have vector B. And assuming that this is at perfect right angle, meaning at 90 degrees, okay, we can find the resultant of this, of the sum of these two vectors, which is just this one here, right? Okay. And you can find this one via the square root of the sum. The magnitude of that vector r is just the square root of the sum of the magnitude of the individual vectors. Okay. From your geometry, this is your Pythagorean theorem. Consider this example here. A cross-country skier skis 1 kilometer north and then 2 kilometers east on a horizontal snowfield. How far and in what direction is she from the starting point? So if you're going to draw that one, the skier skis from 1 kilometer to the north and then skis 1 kilometer to the north here and then 2 kilometers to the east. As you can see, if you're going to draw the vectors graphically, you're actually forming a right angle between the two vectors. Your resultant vector or your resultant displacement is just this one here, which we can find from the square of the magnitude of the sum of the magnitudes. So the resultant vector r is just 1 kilometer squared plus 2 kilometers squared, and then you get the square root, and you find your answer to be around 2.2 kilometers. So your skier from the starting point towards the end point is at 2 kilometers from the origin. So that is your addition of vectors using right angles. In the next video, we're going to discuss adding vectors using their components. Please review your trigonometry and geometry for this. Thank you.